Well, hi and welcome to my shop here on December 29th. I am looking once again at this 1924, 25, 26 radio. And I've gone, let's see, the last video, feeling pretty good about my progress. Discovered something wrong with this control here. Since then, my now good buddy Mark has sent me a whole bunch more information on this radio, which I read through. And now I'm feeling somewhat paralyzed and overwhelmed. So I don't want that to happen. This is actually a relatively simple radio. I should not be having overwhelming feelings about it. So I think today what I'm going to do, something a little bit underwhelming, I'm going to take this out and take a look at it and see if I can fix this or not. And I don't think it's a tough job to get it out of there, actually. So I have taken some time to try to find any information or reference, anything at all, about the very strange variable resistor over here. Read some interesting stuff on resistors generally, early resistors. What is that material? Is that a big sheet of asbestos right here? That could be, you know. Okay, not to worry too much about it. Let's see about getting in the back here. I think I have to undo the wires from the... Some of these will be easy. So resistors were actually quite a challenge back at this point in time, and that's one of the reasons why you don't find many in this radio. Really, any resistors in this radio, aside from these wire wound ones. So coming up with a variable resistor at this point in history was a big deal. I saw one type. I guess I got to take these screws right out. I saw one type. Which involved the compression of carbon discs. You have a big stack of maybe 15 carbon discs, and then you have a screw thing you tighten down. It squeezes the discs down on each other, and this would vary the resistance from quite a bit, actually. Let's see if I can get in here. Too small. That's another reason why these radios use transformers to link stages. The resistors were difficult. The transformers you could make for certain. Yeah, these actually aren't even called transformers. The proper name for these are ultraformers. Ultraformers sounds like a brand name to me. Doesn't want to grab there. Okay, I have to fish out some special tools here. Try to get at that. I'll keep working away on it till I get it off. Okay, the screws off the wires. A nut falling off the back. What fell? How did something fall off here? This is still screwed on. nut that fell out of there. So there's the other nut stuck in there. Okay, we'll leave it in. Clearly we got to look at this under the you can see the damage spot right there, I think. Let's take a look at this under a better camera. Let's see what we can see. So what I'm looking for is, how is the wire connected to that terminal? Can we see it? Just bring in a little extra light here. Maybe we can see on this side. So there's a form. You can see the end of it crushed in there with fibrous ends. So there's a fibrous material, of course, the wire is wound on. Ooh, there's some damage to it. Now, this is probably nickel chromium wire. Hold the camera more steady. I think you can see my heartbeat in the camera shake. Let's take a close look at this broken area here. Right in here. Now, this is where the nonsense happens. It doesn't look broken, it looks really dirty. This looks like a dirty spot, but on the other side, the thing behaved very differently. Seemed to, anyway. Well, there might be a break right in there. Okay, time for a few measurements here. We'll see what's up. Hand me a voltmeter. I have to guess this is a pretty low resistance. That's low. 70 ohms. Oop. Meter's unreliable. 70 ohms. Continuous, so it's not broken. So why the weirdness? When you go over top of this bad spot, it didn't make any difference. Shouldn't make any difference at all. So my whole concept of what was happening with this control is completely wrong. I thought there was a break, and we rotate this into the break. We'd short the break briefly, and that's when the radio went wild. And then we get on the other side of the break, and I just got a totally different circuit happening on the other side. But there's no break, or is there no break? There cannot be a break with that there. Let's measure the resistance here. So it should be about 0. And control's working just fine. So I just went over the break. I didn't feel anything funny happen there. I didn't see anything. Didn't hear anything. So we're back right on the break. Why it didn't do anything? Because I'm pushing on it? Oh, I don't see anything funny happening. Am I in the right spot here? Yeah. Really grindy up in this area here. I feel good turning it up here. I can really feel it on the windings. Maybe it's really the spring is. I can't imagine that's any different. It doesn't feel any different. There's definitely a spot right there. But, you know, there's nothing wrong with this. Why the wonky behavior right at that area? Well, it's just a coincidence. I see something at that spot and I can feel it. What else could be wrong with this? Nothing else could be wrong with this. So what's keeping the windings from shorting against this metal can? It must be a sheet of paper in there. Very thin. Is it shorting onto the can somehow? I can't imagine it. How could it do that? Well, I don't see anything wrong with this. The only thing wrong with it now is I've taken it out of the radio. Wow, that just doesn't add up with what the radio did, does it? It really doesn't. Quite surprised at that. Okay, so we'll put this back in because no reason to have it out. Okay, so I have the volume control back in. Now there's another rheostat right here. And I've been staring at this for quite a while trying to figure out what is it doing. It appears to be in series with this. On the schematic there is one version of this radio as a rheostat controlling the heater current for the modulator tube. I don't think that's what this is doing. This is set all the way so there's no resistance added to this. It's essentially doing nothing, I think. And if that's the case, then its connection, so this connects to the slider, so it's just a short right across here, so it's connecting the upper heater rail to the B minus and also to this. You know, I can't sort it out. I think it's immaterial for what I'm up to. I think what's next on the list is this coil over here. What is going on with this coil? What condition is it in? Yeah, let's take a look at that. I'm going to pull this tube out. So some of the windings are definitely loose on the outside here. The curious thing is the coil that's suspended inside here. So it looks like it's a 3-coil arrangement. One coil, 2 coils, and then a third one inside. It's a pretty common thing in these 1920s vintage radios to have coils inside of coils that would rotate. I think one of the words, a variometer, I think is one of the terms that was applied to it. And the idea is if you do it right, you can actually make quite a variation in the inductive impedance in these coils by doing this. Where it is, a slight touch on this can make a big difference in the operation of the radio. But obviously this isn't something you adjust over and over. You adjust this once and you tend to leave it alone after that. So I believe this is the oscillator tube, and I believe this is the modulator tube. I'm really not sure yet. I'm not sure. So the oscillator tube and the modulator tube work together. The modulator tube has no B+. You know, all these have B+ on them. This just doesn't add up. I mean, the only like each one of these is clearly an amplifier in an IF string. Perhaps the very first tube is a little different, but there's only the antenna was hooked up to the grid of this tube. I don't understand it. I don't understand it. So maybe it's all about this coil and the connections coming from this coil, where they are going. Oh my gosh, so one of these connections comes all the way back to here. Back to nowhere. If I've got a wire here going nowhere, I've got a coil not doing anything up here. This is all loose. This is a horror story. How is this held in? Probably, maybe it's held in just by the connections made to it. If I disconnect all the wires, maybe this coil will come right out. And why would I want to do that? Why would I want to take it out? I don't have a good reason right now to take it out. There's nothing more to see in it. Surely I can test it right here. There's a capacitor sitting right here too, which is an element of what's going on here. So maybe solving this. What do we do with this? This has to go somewhere. Where should it be going? And the bending of this wire is very odd. Up in here. Yeah. Okay. Well, we can start with this tube and follow some of the connections out of the tube base up into the coil here and start tracing from there, I would guess. Okay, let me get things set up so we can do this better. Okay, so you can see where my camera's looking straight down into the coil. Here's what you see. So a lot of this is frayed wire. Like all this is wire where the insulation is gone. It's all frayed out. And I suspect this might have been done to make these wires more flexible. I don't know. It's kind of weird. Or did something get in here and chew this? And we have the rotating coil here, which we can rotate. See, it's a split coil. You have to split it, I think, to get around the shafts that are in the side of this thing. That's all it is. You can clearly see the terminals come here to the. This is the long wire to nowhere, and this one is clearly coming here. Now, nothing else is hooked up to these terminals. So this rotating coil is all by itself on these two terminals. And we have it's lined up with this coil. This you can't see this. It's lined up with the. There's two coils on the outside here. So the rotating one is lined up with this coil, and this one is sitting below it. How are those ones connected? Good question. Are they the same coil? I can see a wire. It appears to be just one coil. Maybe it's one. Now there's terminals on the bottom here, terminals in the top. So you can take a guess. Top terminals, top coil. Bottom terminals, bottom coil. Bottom coil is the one that's hooked up with this capacitor over here. There's actually a gap there. So when you're looking in the camera, you don't see 3 dimensions, right? So you can't see that there's gaps necessarily. Things look connected when they're really not, just because of bad angles. Same thing happens when you're looking with your eyes, though. Well, that's quite a mess of a thing here. I got corrosion all over the place in these connectors. The wire, look at this thing is turning green. It's got heavy patina on it. Chances are this thing is not working at all properly. Especially since I have one wire not even connected to anything. Okay, back ready now to stare at the schematic and see if the answers come forth. Come forth, answers. So where is that coil? Is it this? There's a bunch of them. Or is it this? Where's this? This is the most likely one right here. But there's L1. Maybe somewhere it says something about L1, 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 and L2. Audio frequency chokes. What? Huh? L. No way. L1, L1, and L2. No, there's no way these are audio chokes. What's going on? This must be referring to this up here. We must have. That looks like a choke. And in fact, this is really the radio I think I have. So this one here. Finally seen a reference to this UAUB thing. So these are the Ultraformers Type B, Ultraformer Type A is what this stands for. And what is the difference between A and B? Two different letters in the alphabet. That's all I know at this point. So here we have coil. Here we have these weird coils. Is this what I'm actually looking at? Am I so bongled? This is the rotating coil inside the tube. Well, Jack 1, J1. I just think these are plug-in coils. I can't imagine this is a rotating coil. They wouldn't picture it quite like this, wouldn't they say more about it? L1, L2, So, but the only list of stuff is here, and there's no way that L1 and L2 are those things. Let's go over my new information here and see what we can find. Where is it all? Where is it all? So this is new information I've just received. I've read through it once and once only. This diagram shows your typical, as if there is anything typical back then, typical heterodyne oscillator, and this is the Ultradyne oscillator. The key thing which makes this so strange, you can see in this version, there's the B plus battery, plus side, through this coil to a plate, and through this coil into a plate. So you see both these plates are powered with B plus from this battery. And I come down to this radio. See right here, there's the B plus going to this plate, but it's not going anywhere else. So how does this guy get his B plus? He doesn't. What he gets is a output from the oscillator here. So on the plate here is an oscillating voltage of some amount going plus and negative, plus and negative. And that is what is fed through this primary here. This is probably supposed to be the Ultraformer Type A, my guess. There's a capacitor on it in my radio, on the first Ultraformer. Then they didn't bother showing the rest of the radio. They just put a box there with the headphones on the end of it. They just want to concentrate on this part. So where in here is a coil with a rotating piece? These diagrams show the difference between the standard superheterodyne and the ultradyne arrangement. As may be seen in figure 7, no pickup coil and grid condenser are employed in the ultradyne, and no B batteries connected to the modulator tube. So this is the modulator tube, and it's getting its grid fired up by the antenna circuit with no B plus here. Certainly odd. The plate of which is supplied with high frequency current from the oscillator. The oscillator is pretty standard in the way it's operating. Right, it's grid is being tickled by this coil, which is being tickled by this coil, which is due to the plate current. So you have the plate current affecting the grid, you have feedback. So this guy's humming along, as we've seen. So spirited, he's actually putting out 2 frequencies, probably many more, multiples of the primary frequency. This guy is on and off, on and off, on and off. That certainly introduces a non-linearity in which you can generate the harmonics you're looking for with this circuit. You're trying to get a harmonic, or not a harmonic, you're trying to get a difference frequency out of the local oscillator and the incoming tune signal. You know, when you look at something like this, did the guy think this up one night? He sort of woke up in the morning and went, aha, I got it, and ran down and put this together? Or was he just messing around, trying this and that, and all of a sudden he discovered, hey, this works really well, even though he himself has little clue as to how it's actually operating. I think a lot of that went on and goes on in our lives everywhere. To give an idea of the sensitiveness of the Ultradyne, we may mention the fact that in New York City, using only a coil 3 inches in diameter wound with 60 turns of number 20 wire instead of a loop, broadcast stations in Chicago, Detroit, Cleveland, Cincinnati, Atlanta, and even Aurelia are being heard with good audibility practically every night. The reception is accomplished on the detector alone, or with one stage of audio frequency amplification. With 2 stages, a loudspeaker may be operated with good volume. Thanks to the system employed, the tuning is extremely sharp, and any station within range may be received without interference from local noise. The tuning is, and we don't know what the tuning is. I don't have the next page that matches this. So there you are. So this radio came out, it was like a superstar. Sensitive, selective, curious oscillator circuit to explain why it's so different from the rest. And this radio got beat out by successive radios pretty quick, I bet. So no sign of this rotating coil. Here's another interesting difference here. Here is what would have to be a grid leak arrangement right on the first 2. So this is acting as the detector in this radio. You have a detector here? I don't get it. But in any case, this does not appear here. Yet there's a control on the front panel of this radio called grid leak, and it's aimed right into this part of the radio. So was there once something like this going on? I think this is anti-Ultradyne. This kind of stuff is dependent upon, plate voltage, all this kind of stuff. It's a very typical circuit, but not with the plate hooked up like this. So curious to me what's going on with that. Isn't that supposed to be way down the line? Like if you're doing this with a super heterodyne radio, then there's got to be IF coils and stuff down here, and IF frequency and all that, and then you detect way at the far end. Why are you doing this here? So in a lot of the older radio schematics, you'll see that the mixer tube is called the first detector. Maybe it was called the first detector because of this. Gone from here. Yeah, I'm not getting, oh, let's try more. There's more. I got more to look at. Let's look at more. Thank you again, Mark, for sending me all this. Super selective. It's the improved super heterodyne. A couple of handwritten notes on R9045. just take a look through here very quickly. I've already read this. In this schematic diagram, the numbers and letters refer to the following parts: A and G, aerial and ground binding posts; L1, primary of tuning unit; L2, secondary of tuning unit; L3 and 4 are the stator and rotor of the sensitizer coupler. Oh, wait a minute. Wait a minute here. L3 and L4 are the stator and rotor of the sensitizer coupler. The sensitizer coupler. Let's look at that. This must be the sensitizer coupler. What is it? L1 and which one was that? L1 and L2. This is L2 here, I think. No, this is L2. This is L2. This might be L1 here. This is right off the antenna, I believe. Can we not see it? Can we not see it? Show it. No, can't see it. So, and clearly here it's saying this tube is the modulator and this tube is the oscillator, and this means that this tube here should get no B plus on the plate. Let's go see where it goes. Through there, going through the first IF. So at this point there must be an IF frequency in here, coming down the oscillator. No plate voltage. So it's clearly the Ultradyne combo modulator oscillator system here, as I'm now beginning to become more familiar with. So why the jack here? I get just different coils you can put in, or is this just they're showing this as a? It really does look like a jack, doesn't it? It really does. Let's see what else it says. L1 primary tuning unit. Okay, L3 and L4 are the stator and rotator. L3 and L4. L3 and L4. These two. So this must be a plug-in coil of some sort. So this and one of these, it's got a big R here. I wonder if that means this is the rotator. This one's rotating around this one. It really wouldn't matter what it. And then the output is varying, and it's fed. Where's it fed? It's fed. It's just fed into here. Out of here comes the IF frequency, which we think is 75 kilohertz. The oscillator is running right up near the broadcast frequency to give the 75 kilohertz difference. 75 kilohertz, you know, that's plus and minus 75 kilohertz. That's not very much. That's this radio would pick up images like crazy, I would think, unless somewhere there's some pretty sharp tuning. There's the difference between 75, you know, like 150 is a doubling. So, yeah, I'm not going to think of these. Don't think more about it. So here they have these different jacks, so you could plug in headphones here. Maybe it's not quite loud enough, so you plug your headphones in here. You want to drive a speaker, you plug it in here. You get the benefit of these two audio boosters here. But you didn't need these. In fact, in the instructions somewhere it says if you're having trouble with the radio, plug your headphones in here, pull these two tubes out, and then use them as substitutes for these tubes. Because as I'm reading this material, I'm realizing what people are struggling with back then is they have no instruments whatsoever. They have this radio just like I have on my bench. Must have been freaking them out looking at the thing. No instruments. So how do you go about figuring out why your radio doesn't work when you don't even own a voltmeter? Well, the instructions explain a few things that you can do. It's kind of interesting. Maybe we'll eventually look at them. Not helpful to hear though. I'm not getting anywhere here. Yes I am. What am I saying? I'm getting this rotating one here. So we should look for the connections of the rotating coil going out to the primary side of the first. Well, one to the primary side and the other one to the plate. Okay, let's see if we can see that. So again, I'm not exactly sure which tube I'm talking about here. We'll go with the first one. It seemed to be what what it was suggesting. Yeah. Oh, I'm using automatic focus here, so bear with it. So so the grid gets the antenna here. I mean, that's the end of that. The grid gets the antenna. Where's this coil going? How did it ever get out here? Because this guy's grid gets the output of this transformer. What are you doing? Okay, so we'll go this way. So we start here. The coil is on these two terminals. One of them goes down and picks up the positive. It's actually the negative rail of the heater string. Connected to the negative rail of the heater string. And the other one is connected way out over here. Oh my gosh, it's connected to nothing. So it would be connected to this coil arrangement that we had here. It was under no, it was on the secondary side. It was soldered onto this little wire here. Where? Here. That little wire. And then from there goes through this resistor thing and then to the grid. It's coming from the rotating coil. One lead going to the negative side of the heaters, and the other one coming all the way back here to intercept the secondary side of that coil. So you really literally have the raw, almost raw antenna signal being fed into that coil down there. Yeah, really. That's what this would look like. It would look like the rotating coils hooked up to the antenna. That's not at all what the schematic shows. The schematic shows the rotating coil. What did the schematic show? Short-term memory here that I'm hooked up to here. Where there's a capacitor. So what is this thing hooked up to anyway? Where does it get into the circuit? I can see some connections from this lower coil beating the... Hey, why don't we do this? Okay, I got a better idea. So this is the oscillator control capacitor. Let's trace around that and see if something comes to light. So I see one connection again going to the negative of the heater string. Bearing in mind the heater string is also the cathodes of these tubes, and the other lead, a little hard to see, going down under the capacitor and connecting to the lower coil and to this tube. So okay, so to clarify now, two leads coming from the capacitor, one goes to the heater. Why did my light just go out? I'm all thrown off. One of my lights just stopped working in here. It's just enough to, overload my little poor brain. Okay, one more time. Coming down here onto the positive of the heaters, onto the negative of the heaters, and the other side going to one of the coils. Up 3 coils here. Three coils. Oh my gosh. So where are these two coils? If there's three coils there, one is the rotator, this one. The other one is the one that's right outside it, interacting with it. Then there's another coil down low. Well, that would be this. They're saying they stuck that. On the schematic here, all this stuff is right on the end of the radio. Is it possible that all this stuff is actually tucked right in the middle of the radio because the wires have to go to the middle of the radio anyway? I don't know. Well, that's what it appears to be. It appears to be that that coil I'm looking at is actually all this stuff. What about this? Where's this? This has to be in there too. There's too many coils. There's too many coils in the schematic. 1, 2, 3, 4, 5, 6 coils in the schematic and 1, 2, 3 in the radio. That's not a very good ratio. It's a whole pile of coils are missing. Wait a minute. No, I've got the that antenna, the Steinite. The Steinite. So this is out and Mr. Steinite is in. And at that point, could it be that they totally messed this whole thing up? Just messed it right up. Trying to use not the Ultradyne knowledge that I have packed in my head, but using other knowledge packed in their head, not the right knowledge. Well, I end up kind of half converting this radio into a more standard heterodyne radio by accident, on purpose. Who knows? Who knows how many different radios this radio's been? Who knows how many people have had their hands on it, messing around with it? I'm in a long line. You know, this radio's been around almost 100 years. I'm not the second guy to work on it. So we could have multiple mess-ups in here. This radio could be so messed up that there's no room for more mess-ups for me. It's just fully messed. The way forward with this is pretty pretty questionable. Circuit diagram. I gotta make up a circuit diagram of this radio. Looking at those schematics, I'm not sure it's helping at all. Oh, okay. Well, that's what I'll spend my day doing, I guess. So tomorrow I'll have a schematic in hand of what is really in this radio, how it's wired. And having made that promise now, I've committed myself. Son of a gun. Well, you have a great day, because I'm going to be drawing a schematic in here, probably losing the 5 hairs I have left. Thanks a lot for watching so far. Sorry, not too much progress today, but that's how it goes.